this video, we will be discussing about construct k palindrome strings. Given a string s and an integer k, return true if you can use all the characters in s to construct k palindrome strings or false otherwise. So what they are saying is that in the input, we are given a string s and we are given another integer k. Now we need to identify that if we use all the characters in s, then are we able to create k palindrome substrings or not? If we are able to create, then we need to return a true, otherwise we need to return false, right? So we need to find out whether we are able to create k palindromic strings, right? Now, first of all, what is a palindrome? So a palindrome is a string that if we read it from forward, then also it is the same. And if we read it from backwards, then also it is the same. So for example, I have a string like this, right? Now, if I read it from forward, it will be A, B, B, A. And if I read it from backwards, then also it will be A, B, B, A, right? So this is a palindrome string. Then if let's suppose I have a string like this, right? Now here also, if I read it from forward, it will be A, B, C, B, A. And if I read it from backwards, it will be A, B, C, B, A. These are same, right? So this is also a palindrome. But if let us suppose that I have a string E, A, Z. Now, if I read it from backwards, it will be ZAE, right? This is not a palindrome string, right? Now, if you make some key observations over here in a palindromic strings, that this is a palindromic string, right? How is it a palindrome string? Because if you see, the first letter and the last letter is the same. And that is the reason that when we read it from backwards, then it's same, right? Then the second letter and the second last letter is also the same, right? So a palindromic string has this property that in this each character will have even frequency, right? If you see, A is coming two times, B is coming two times, right? Now this is the case when we have a even length string. Here the length of the string is 4. When we have an odd length string, here the length is 5, right? This is odd. Now when we have an odd length string, in that case there is just one element in the middle which is of frequency 1, right? Because even if I reverse my string, this character will not change its position, it will stay here only, right? So only this is the character which appears odd times, right? Rest all the characters match, right? Rest all the characters have even frequencies. These characters and these characters will have even frequencies, right? So what did you understand? That whatever are the characters which have even frequencies, they can always create a palindromic string, right? But if there is a character which has odd frequency, so in that odd frequency, right? If I'll remove one, then it will become even, right? Odd means that it can be 3, 5, 7, or 9. If I remove one from them, they will become even. That is 2, 4, 6, or 8, right? So that one which I had to remove, that one has to be adjusted in the middle always, right? So if there are two such characters which are having odd, then we cannot adjust both of them in the same string. If we'll do so, then it will not be a palindromic string, right? So now when you know the concept of odd and even in a palindromic string, let's come back here. Right. Now here we need to check whether we are able to create k palindromic strings using all characters in string S or not. Right. So now if I ask you over here that what is the maximum number of palindromic strings that you can create out of this string S? Right? What is the maximum number of strings that you can create? Palindromic strings. So see, is this a palindromic string? Yes, it is, because if I read it from forward, it is A. If I read it from backwards, it is also A, right? So one length string is also a palindromic strings, right? So if I want to find out what is the maximum number of palindromic strings that I can create from string S, so it will be, I can take all the characters individually, right? So this is one string, then N, N, A, B, E, L, L, E, right? I can create all the palindromic strings of length 1, right? So this 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the maximum number of palindromic strings that I can create from string S, right? And this 9 is nothing but the length of the string S, right? So now if I ask you that your K is 10 or 11, basically something greater than 9. So will you be able to create k palindromic strings? No, right? Because you don't even have that many characters in your string S, right? So 9 was the maximum number of strings that you can get, palindromic strings, right? So if in any case this k is greater than 9, right? Then your answer is going to be false, right? Because we don't have that many characters. So there is one condition which you can put, that if k is greater than the length of the string s, right, then you can directly return a false, right? Now, if I ask you that out of this string s, what are the minimum number of palindromic strings that you can have? What is the minimum? So if you see over here in this string, a is coming 2 times, B is coming 1 time, E is coming 2 times, L is coming 2 times, N is coming 2 times, right? So basically this is the frequency map of this string S, right? Now if you see over here that how many characters do we have which are having odd frequency? So that is only this one, which is B, right? So then that means B will always create a palindromic string of odd length, right? Now, if let us suppose that here we didn't have an E, right? So in that particular case, its count would be 1 over here, right? Now, there are two characters which are having odd frequency, right? And as I said that in a palindromic string, either there will be no character with a odd frequency, or there will be just one character with an odd frequency, right? So when here I have two such characters, so they will always be present in two different palindromic strings, right? I cannot put B and E together in one string. Otherwise, it won't be a palindrome, right? And then the others which are having the even frequencies, they can be adjusted anywhere. A and A can be put here, N and N we can put here, and then L and L. Or we can put all here, A N L, L N A, or anything. Or they could also create a separate string over here, right? So that is also possible. But we are identifying minimum, right? So basically, the minimum number of palindromic strings will be equal to the number of odd frequency characters that we have in our string, right? So if we change this string back, so E was appearing 2 times, right? So here we are having only one character with odd frequency, right? So basically, 1 is the minimum number of palindromic strings that we can have, right? 9 was the maximum, and 1 is the minimum. So basically, we can have minimum 1 palindromic string and maximum 9 palindromic strings. Basically, our k has to lie within this range for the answer to be true. If k is greater than 9, it is false. If it is less than 1, then also it is false, right? So greater than 9 condition we have already handled over here, right? And then when you have identified that how many characters are there whose frequency is odd, then you can check that if this k is greater than equals to this count, then that means it is within this range. So you can return a true, otherwise you can return a false, right? So simply what you will be doing is, first you will be checking this condition, right? Then you will be creating a frequency map of the string S or a frequency vector. Then in this frequency vector, we will count that how many characters are there where the frequency is odd, right? And then we can just check that if this k is greater than equals to that odd count, then our answer is going to be true. Otherwise, it is going to be false, right? So let's quickly look at the code. So first of all, we will put our condition that if k is greater than s dot length, then we will return a false, right? Then we will create a vector for counting the frequencies. So its size is going to be 26 and the frequencies will be 0 initially. We are only having A to Z lowercase letters in our string. That is why we have taken the size as 26, right? Then we will iterate for each character in string S and we will update its frequency. So we will do ch minus A so that it gives us the index. A will be 0, B will be 1 and so on, right? So once we have updated the frequency of all the characters, now we need to count that how many odd frequency letters are there, right? So now what we will do is that we will iterate in the frequency vector, which will give us the frequencies of all the letters, right? Now we will check that if in any case this frequency is an odd frequency. Basically, x modulo 2 is not equals to 0, so then that means it is odd. So in that case, we will increment our odd by 1, right? Now at the end, we just need to check that if our k is greater than equals to odd, then we need to return true, otherwise we need to return false. So let's quickly run this. So now here if you see, we are iterating once in our string s, right? So basically if the length of the string is n, then this is running n times. And then here we are running a for loop in the frequency vector whose length is 26. 26 is a constant, right? So we can say that the time complexity here will be order of n. Coming towards the space complexity, so we have taken only a frequency vector of length 26. right? So we can see that the space complexity over here is order of 26, and 26 is also a constant. So we can assume that the space complexity is constant. So let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.